Hello friends, today we are going to discuss a problem from TIFR 2020 GS Mathematics examination. We are going to discuss question number 17, and it is from linear algebra, and the concept is basically from diagonalization of linear operators or linear transformations. So the problem is that which of the following statements is correct about every linear transformation from r cube to r cube, which satisfies t cube minus t square minus t plus I is equal to 0. So we are given four options. The first option is that t is invertible as well as diagonalizable. The second option is t is invertible but not necessarily diagonalizable. Third option is t is diagonalizable but not necessarily invertible. And the last one is none of the other three statements. So we are given that t is a transformation which satisfies this equation. And one thing what we can say is that clearly the minimal polynomial of this linear operator divides the polynomial x cube minus x square minus x plus 1 because it is one of the annihilating polynomials of t. Because this polynomial we are getting from this above equation only. Because we are getting that this t satisfies some polynomial, that is the polynomial is nothing but x cube minus x square minus x plus 1. So if you just try to factorize it, what we are going to get is it's nothing but equal to x plus 1 times x minus 1 whole square. So minimal polynomial has the property that it will divide every annihilating polynomial of that particular linear operator. So it will divide this polynomial also, that is x cube minus x square minus x plus 1. This polynomial also, minimal polynomial of t, will divide. So what we can say is that the minimal polynomial of this particular linear transformation, it could be the polynomial x minus 1, or it could be the polynomial x plus 1, or it could be something like x minus 1 times x plus 1, or it could be the same thing like x plus 1 times x minus 1 whole square itself, but we don't know about it. Polynomial divides this particular polynomial, that is x cube minus x square minus x plus 1. What we can say is that, and depending upon the different options we have seen for minimal polynomials, but we don't know which is the minimal polynomial here. If it is going to be x minus 1, then we have like the minimal polynomial has root 1. If it is going to be x plus 1, then we have that the minimal polynomial is going to have root minus 1. Or if it is something like x minus 1 times x plus 1, the minimal polynomial will have root 1 and minus 1 and so on. So but we don't know exactly what is the actual minimal polynomial. So depending upon the roots of the minimal polynomial, what we can say is that t could have eigenvalues like 1 and minus 1, or simply 1 or simply minus 1. All these cases can come up. But we are sure that 0 is not a characteristic 0 is not a root of minimal polynomial. And we also know that the minimal polynomial and the characteristic polynomial both have same roots. So here in this case, the characteristic polynomial will also have will also not have 0 as the root. So from which we can confirm that t is actually an invertible map. So in this case, we are getting t as an invertible map. Now next our option is to decide whether it is diagonalizable or not, whether t is diagonalizable or not. So there is one necessary and sufficient condition for diagonalizability, that if the minimal polynomial of that particular operator is a product of linear factors, then we can say that that particular operator is actually a diagonalizable operator. So in this case, as I told you, we have three or four cases which can come up for the minimal polynomial. We don't exactly know which is the minimal polynomial. It could be, as I told, x plus 1 or x minus 1, or it could be x plus 1 times x minus 1, or it could be x plus 1 times x minus 1 whole square. So since we are not given any other data, we cannot confirm whether it is diagonalizable or not. If suppose we are getting the minimal polynomial to be x plus 1, then we can say it is diagonalizable. Or if we are getting it to be x minus 1, we can say it is diagonalizable. And suppose you are getting it to be x plus 1 times x minus 1, still it is diagonalizable. But if you get the last option, that is x plus 1 times x minus 1 whole square, in that case it will not be diagonalizable. So what we get here is t is invertible, but it is not necessarily diagonalizable, because we don't know exactly about the minimal polynomial. We are not given enough data about that. Thank you for seeing this problem.